So this will probably be the shortest video that we'll do in this series, because it's time to talk about the Singleton pattern. Now, if you're not familiar with this playlist, first of all, welcome. What we're doing here is that we're walking through all of the patterns in this book, Head First Design Patterns, one by one. So each video, one design pattern. In other words, if you're not already subscribed to the channel, be sure to subscribe to the channel so that you won't miss the next video on the next pattern. Beyond that, this book, Head First Design Patterns, is a great book if you're new to design patterns. If you're looking for more like a reference book or something like that, I'll put a link to the book by Gang of Four in the description. But if you're new to design patterns, I highly recommend you to get this book because it's very pedagogical. Link in the description. Now, let's get into the Singleton pattern. So here's the thing. I really want to stress that many people argue that Singleton pattern actually is a code smell, that you should not actually ever use the Singleton pattern. The fact is that as I currently stand, I'm one of these people. So I'm only going to cover the Singleton pattern for the sake of completely covering the Head First book, and also because it's actually a very interesting mechanism. You'll see why. But the first time I learned about Singleton pattern, I went, whoa, I had no idea you could do that. It's actually quite interesting. But it's extremely important to remember that many people argue that you shouldn't ever use the Singleton pattern. I'm not going to go into depth as to why, but let me read you the definition of the pattern first, and then let's just briefly talk about why people argue that you shouldn't use it. By the way, I've put a few links in the description to videos that make a far better job of explaining why you shouldn't use the Singleton pattern. But here's the definition. The Singleton pattern ensures a class has only one instance and provides a global point of access to it. Just think about that. The Singleton pattern ensures that a class has only one instance and provides a global access to it. In other words, to that single instance. So in other words, it's like you have a class and Singleton pattern helps you to make it impossible to instantiate that class except for a single time, and whenever you want an instance, you will inevitably have to use that instance. The way it actually works is that whenever you ask for an instance, you always get the same instance. So there are these two things, right? One is about making sure that you only ever have a single instance, and one is providing global access to that instance. Now, the way I understand it, the main critique towards Singleton pattern are essentially these 2 points. One of the first things we learn when we talk about programming is to avoid globals. It's to actually scope variables and functions so that not everything is leaking into the global namespace. For one, it's extremely difficult to control because you have lots of different things that might be ambiguous out of context or might be difficult to understand out of context. But probably more importantly, whenever you leak something to the global namespace, whenever something is globally accessible, that thing might change without you knowing it. It's much harder to reason about your program when you don't have control, when you don't necessarily know the scope of a particular thing, because that thing that you are interacting with, anybody within the whole program might change that thing, assuming it's changeable. It might, of course, not be changeable. But any piece of code within your program might be able to touch that thing. So again, it's like programming 101 is globals are bad. But again, if you want to learn more about that, check out the videos I'm linking in the description. The second point, about making sure that you only have a single instance. That too is kind of an absurd idea. If you think about it, that's an assumption. You're assuming that in the future, I will only ever need a single instance of this particular class. That isn't necessarily true. And especially if your application is growing. So just to take sort of an example, think about building a chat application, for example. So you might first think that the chat is a singleton, like you want to be able to reference the chat in which users are from wherever in the program. So in order to make it more convenient for yourself, you make a singleton and you have a global point of access to this instance of the chat. But then as time progresses, you start to realize that actually we're being very successful with this chat and we want to have multiple chat rooms. And if the singleton chat is managing users who are currently connected to the chat, that's essentially a chat room. It's just that when we were designing it as a singleton, we didn't think about the fact that in the future we maybe actually want multiple instances of this thing that we currently really believe that we only want a single instance of. So the whole idea about Forcing the application to only have a single instance of something only really makes sense if you 100% know that now and in the future you will only need a single instance of that class. But I would argue that we almost never know that. So it's better just to not make that assumption. So there's this great saying that one man's constant is another man's variable. And if we look at it from a different perspective, singletons might make testing, if you're familiar with unit testing, very difficult, because whoever is requesting the singleton will definitely get a particular instance. But in testing, you might, for example, want to mock that. And that becomes a lot more difficult when you have this sort of global object, this global single instance that you're always reaching for. So even if within the application you actually want a single instance, as soon as you do testing, there's almost always a second needed instance because you might want to mock that within the testing of your application. So again, one man's constant is another man's variable. And I think that's really profound and really speaks to the dangers of Singleton pattern. And just to emphasize what we can do instead, there's a guy called Miško Hevery, apologies if I'm mispronouncing his name, who says that it's completely fine to have a single object, only a single object within your application. But it's not fine to force, to make it impossible to create a second instance. It's not a good idea to make it impossible to create a second instance, because you don't necessarily know whether you at some point actually want a second instance. But it's completely fine to, within your application, only have a single instance of something. Completely fine. But the singleton pattern, let's now get into it, is designed with the intent of making it impossible to create a second instance. Making it impossible to not reach for this globally available instance of whatever this singleton is. Let's now get into it. So here's the way it works. You have a Singleton class, and this is the thing that you want to only ever have a single instance of. So if we're talking about a chat, like when we were saying that you have a single chat room, only ever a single chat room within the chat application that you're building, this would be the chat. But let's now call it the singleton. So actually, you might immediately think about single responsibility principle, which the book also discusses, that you're actually asking the chat room to now both be a global point of access to the one true instance of the chat room, and you're asking it to behave as a chat room. Or you could even slice it into three parts and say that you're asking it to A, behave as the global point of access to the single instance of the chat room, B, ensure that there only ever exists a single chat room instance, and C, to do whatever the chat room was originally intended to do. So even that's a bit shaky when we're talking about the singleton pattern. But what actually goes into this singleton class? Here's the thing. The key about singleton pattern, and this is why I think it's actually extremely interesting and what sort of messed with my head the first time I heard about it, is that the constructor of the singleton we make private. When I heard that, I had never thought about that before. I mean, the constructor is public so that you can construct instances of the object. But you can actually make the constructor of a class private, which means that from the outside, people can't construct that class. They can't say new singleton. Only singletons can instantiate singletons. But if you can't make a singleton by saying new singleton, then you have no singletons that can make new singletons. So then you're in a situation where you're saying, wait, but how do I actually create the first singleton? How do I actually create something which has the access rights to create a singleton? And that's when static methods come in. Again, a lot of people argue that you shouldn't use static methods. Check out the description for more links. But that's when we use static methods, because a static method is a class method, right? So a static method on the class singleton is still within sort of the namespace of the singleton, which means that it actually has access to the private constructor of the singleton. So let's draw the parts and then let's talk about it. So if we draw variables up here and methods down here, then we have a static method. So let's say a static method that returns a singleton. So in other words, it's a static method that returns an instance of this class in which it resides. And let's call this method getInstance. Sorry for the lack of space. Let's expand that so that we have the room. So the singleton is a class that has a static method called getInstance. And when you call the static method getInstance, right? Remember that we're calling it on the class singleton. So we're saying singleton capital S getInstance. right? That's the way we're calling it. It's a class method. We are not instantiating a singleton. Singleton s equals new singleton, and then calling getInstance on that s. That would be the way we would interact with an instance method. But this is not an instance method, it's a static method. So we're not doing this. And again, I'm not crossing this over to say that this is bad. I would rather say that this is better. But we're crossing that over just to emphasize that that's not the way you do it when using the Singleton pattern. When you're using the Singleton pattern, you do this. You call the method getInstance on the class singleton. So, back to this diagram here. So the singleton then has a method called getInstance which returns a singleton, but it is a static method, so we call it on the class singleton. The second important piece is that the singleton then has a static variable of type singleton, which essentially is the instance. So this would of course be a private variable so that you couldn't globally access this singleton instance without going through the getInstance method. But we have to draw it here just to be able to sort of convey the point with UML. So the point is essentially that the method getInstance would first check if there is an instance within this static variable called instance that holds a variable of type singleton. And if it does exist, it will return that instance. But if it doesn't exist, it will instantiate it and save it into this variable, so that the next time we call getInstance, there is a variable here. Because if you think about it, this is static and this is static. The getInstance method is static and the instance variable is static. So there is only a single instance of this variable instance because it's a class variable. It's a static variable. And this is essentially it. This is why I'm saying it would be the shortest video. Let's look at this in code as well, and I think you will really grasp how this works. So let's remove this part and let's try to keep this singleton UML here. So with some pseudocode, here's what happens. We have a class called singleton. And this class, the constructor of this class, usually it would be something like public singleton. And then we would potentially do some work here. And this constructor essentially then is public. That's the way we would normally do it. But the way we do it now is that we say, actually, this is private, which means that you can't say new singleton elsewhere in the code. If you're not within the Singleton class, you cannot say new singleton because the constructor is private. So it's not possible to instantiate a singleton. Now, so the constructor is private, and that's fine. Second piece, we then have this method, the static method that returns a singleton and is called getInstance. So let's define that. So we have a public static method. We have a public static method that returns a singleton and is called, sorry, I'm running out of space, I'm using 2 lines here, and is called getInstance. And somehow, I'll just put ... here, somehow this method will return a singleton instance. And we'll make sure that we always get the same singleton instance. And of course, this means that back over here, we still can't do new singleton, but we can do singleton with capital S. In other words, the class singleton dot get instance. This we now can do because there is a method, a public static method that returns a singleton and is called getInstance. But let's now talk about this implementation. So what's this implementation? Well, this implementation depends on this thing that we talked about here. The fact that we have a static variable that stores a singleton and is, for example, called the instance. So let's define that. So here we define in the class a static variable. So let's say static that is private, so private, and it holds a singleton. So we say singleton, and I'll just call this instance, just like here. So sorry for the very crammed code, but we have a class that's called singleton. This class singleton has a static private variable called instance that holds something of type singleton. We then have a private constructor that currently does nothing, but the fact that we have a private constructor means that we can't instantiate this class from the outside. And then we have this method, public static singleton getInstance. In other words, we have this public static method that returns a singleton and is called getInstance. And the only missing piece now is the implementation here. So let's talk about the implementation of this method. What it does, if you only wanted global access to an object, what you would do is that you would return a new singleton. This would actually be possible because we're now in the Singleton class, so it doesn't matter that the constructor is private. Because we're in the Singleton class, we actually have access to the constructor, so we can say new singleton. But we don't just want to do that, because we actually also want to make sure that we're only ever using the same instance. So this is why we first check if this instance, the private static singleton that we have called instance, is null. So we say if instance equals null, then we need to instantiate. And we don't just instantiate, we set the instance variable, this variable, to be equal to a new singleton. So we instantiate the singleton and we store it in the variable instance, which is this variable, the static private variable instance. And then we close this if, and then we could either do this with an else branch or without an else branch. Let's now do this without an else branch because I think you can figure out how to do it with an else branch. So if there is no instance, then we set the instance to a new singleton. And after that, we simply return the instance. And that's the implementation of the public static method getInstance that returns a singleton. And that's actually the whole class, except let me put ... here to emphasize that, of course, the singleton probably has other responsibilities as well. It's probably not just a singleton, it also does something that makes sense in your system. So again, if it's a chat room, it needs to do chat roomy stuff. But that's the whole of the class, so let's close that as well. So let's just quickly review this before we wrap up. So we have a class called Singleton, and we want to have a single instance of this class globally. We want to forbid ever having multiple objects of this class. So what do? Well, we make the constructor of the singleton private, which means that you can't construct the singleton from the outside. We can't do this. Instead, we want to do what? We want to have a method called getInstance on the class singleton, and we want to make that method public so that we can call that method and get the same instance every time. And how we achieve that is by introducing a public static method called getInstance, and that method will return a singleton. And because that lives on the class singleton, we now suddenly have access to the private constructor. So that method can then return a new singleton. But because we want to make sure that we always have the same singleton instance, we store the singleton instance that we create. The first time we create it, we store it in a static private variable containing a singleton called instance. So we check, we say, is the instance that I already have, potentially already have, is it null? Because if it is, then I haven't created it yet, and this is the first call to the getInstance method. And so if it doesn't exist, then I'll simply create the singleton, call the private constructor to instantiate the singleton, and store that instance in the private static variable instance containing a singleton. So I'll store that instance that I created. And then I'll simply return this instance that I just created. Which means that the second time somebody calls getInstance, in other words, does this call, singleton.getInstance, the second time somebody calls it, then the instance will not be null, which means that we won't execute this portion of the code, which means that we'll go directly here and simply return the instance. And that's the Singleton pattern. Again, it's kind of cool because you're making use of a private constructor, so it's kind of like architecturally or technically kind of interesting because perhaps you have already thought about it, but I for sure hadn't thought about it the first time I heard about it, that you could have private constructors, so it's kind of cool. But again, I would strongly advise you not to make use of the Singleton pattern. And if you want to know more about why, please check out the links in the description. But to wrap up, let's finish with this definition. The Singleton pattern ensures a class has only one instance and provides a global point of access to it. And that's the Singleton pattern. So I hope that makes sense. If not, please do ask anything in the comments. Beyond that, if you're interested about this whole thing about why it would potentially not be a good idea to use Singleton pattern, please feel absolutely free to discuss that in the comments and we can have a conversation about it. Also, if you're on either side of that discussion, please feel free to vent in the comments because I'm sure that other people will find it very useful to see your opinion on the matter. Now, This was a short video, but there are tons of patterns left in this book. If you're not already subscribed, be sure to subscribe so that you won't miss the next pattern from this book. Beyond that, if you're new to design patterns, be sure to get this book. The link is in the description. And finally, thank you very much for watching, and I'll see you in the next one.